Is this going? All right, cool. Hello, my name's Josh. This is my homework 2 submission for M2 root finding, problem 1, parts 1 through 1.1 through 1.6. Okay. Here's part 1.1. I chose solving this using the secant method. Here's what it asks of us. 2x minus cosine x equals 0 up to 5 decimal places. Chose secant method. I have my iteration set to 8 to get our 5 decimal places. I might have one extra iteration that I need. You get to the initial guesses, the corresponding y values of the initial guesses, the array for the guesses, values displayed. What else? Here's the loop. Here's the secant formula for x. Here's our function for y. It's also indexed with the for loop to run it. And then we display our different values of x because that's what we're looking for, our root. And yeah, I'm going to go ahead and run it. So as you can see, you get the arrays. I'm not going to click on them because it's going to open up this and whatever, but you get your initial guesses here. We did 0 and 2 to catch, or not to catch, it's secant, to be close to the value. So yeah, we start off with 0.437, and as you can see, secant method taking over, jumping to its value quickly, and we wanted 5 decimal places. You got 6, but yeah. So there's secant method that I used on 1.1 for this function or equation. Okay, part 1.2 asks us to solve this up to 4 decimal places. I chose bisection. You got our brackets. You got our function here for the left bracket, function here for the right bracket. Our bisections that we're going to do for our loop. You have your x's, your x equation, your equation for bisection, which is just picking the midpoint of your bracketed values. And then it just keeps on taking these midpoints for the better bracket. That's what this if statement does. Finds the bracket we need to convert to. There's our function again. The final equation goes up here. And then, yeah, here I'm going to run it now. Here, let me clear first. And then we converge to this value here. And we've got 1, 2, 3, 4, 5, or 1, 2, 3, 4, 1, 2, 3, 4. And it asks 4 decimal places. All right, so that's my bisection code for part 1.2. 1.3 asks us to solve this. I chose to use Newton's. However, there's no real values. And you can see that your discriminant here yields a negative value. 1 minus 4 is negative 3. And if your discriminant's greater than or equal to 0, I have it so that the code runs, you do your Newton's method, you converge to your value. However, if it's less than 0, which is what this else statement does, you have printf. The function has no real root solutions, which you could definitely solve for an imaginary solution. However, this says the solutions here that I read just said like it didn't tell me to make this fprintf, but I made it because it didn't mention solving for imaginary values. But yeah, pretty simple code, Newton's method. Just this discriminant and this if statement being added to catch those imaginary values. All right, part 1.4. What time am I at right here? 5 minutes, okay. Part 1.4 asks us to solve this. It's a very similar graph or plot when you plot them to this function here. So same thing, except I wasn't using Newton's again. I wanted to experiment with other ways of separating these imaginary equations from real ones that have real roots. So you have your initial brackets, the corresponding function associated with those brackets, similar to our bisection here. You have your if statement. So if your y is only positive values, meaning that it doesn't go under the x-axis at all, the function has no root solutions. And if it's only negative values, so let's say it's like concave down and it's under the x-axis, like a quadratic, like a parabola that's concave down and under the x-axis, and never touches it, it has no root solutions as well, is what it displays. And I'm sure I could put like no root solutions because what I just mentioned, like the concavity and it being on the x-axis, but for right now I just have that. And you could definitely find an imaginary solution if you put like initial guesses, like I don't know, like something like that. But once again, based off what this said, I'm just going to leave it so that this just basically says that there's no root solution. You get your loop here, false position equation. The function we were given, format of the x values that are displayed along, so you can see your 4 decimal places, and this one was up to 3, but it doesn't even matter because there's no root solutions. This one's not going to matter either. And then you have how, similar to bisection, how you choose which endpoint you're going to take and how you're going to get your next midpoint. And then the equation again. And then, yeah. So I didn't actually run this. Let me run this. Sorry. Let me clear this past one. So as you can see, no root solutions for that one. Clear, so you'll see the function has no root solutions for this one as well. Next one, fixed point using ARI, which is the MATLAB function we were given. Yeah. So the fixed point, we're talking about this in class today about using lambda to help you converge that value faster. I'm not sure if it would converge not using lambda within these amount of iterations using the fixed point. But yeah, I'm just going to run. It's pretty simple. You get your initial lambda, you multiply it by the function. Display that, set it equal, because it's like your new value is sort of, and display. So as you can see, up to 5 decimal places. Let's see if I can get here. And we have plenty. But yeah, using the new lambda function makes fixed point, it accelerates fixed point a ton. And I'm not sure if other methods would work with this. I just went straight to fixed point, but I need to look more into this area function. 1.6. This is like our test question. I bracketed not the first positive value, I believe, but the second one. If you look at the graph, bounds right here. Corresponding y's. I've already done a bisection and a false position, which are pretty similar. So I'm not going to get too deep into it. Your bisection count, the loop with the function, and the equation we were given at the start, x displayed, picking the right bracket right here, based off your midpoint, multiplied by it to slowly converge that value, the basic midpoint picking equation, and then display x. And I'm going to go ahead and run that. And we get our value, and up to 5 decimal places. I have a display extend here, I do, so I gotta scroll up. Yeah, let me put just more iterations in, because I'm not sure if that hits 5. And let me do this real quick. Sorry. No. I just make more iterations. All right, that hits it. Okay. Cool. And yeah, that should be all. I think I've ran all the code I need to run. I've ran this one. Just run all these real quick again, just to say I did it. All right, there's 1.4, 1.3, 1.2, 1.1, and I use secant, bisection, newtons, false position, fixed point, and then bisection. And yeah, I just asked 1.1 through 1.6. All right, thank you.